Hello everyone, this is the second video about the Pythagorean theorem. In this video, I will explain how to prove the Pythagorean theorem and how to determine whether a triangle is a right triangle or not. So after watch this video, you should be able to understand how to prove the Pythagorean theorem, and also you should be able to determine whether a triangle is a right triangle or not based on the length of its sides. Okay, now look at these triangles. Both of the triangles are right triangles. The first example is triangle ABC. A is the right angle. Side BC is in front of the right angle. So side BC is called the hypotenuse, while the other sides which are AB and AC are called legs. Sometimes we give the name of the sides of the triangle with one small letter like this example. So we can state that side B is called the hypotenuse because in front of the right angle. And then the other sides R and Q are called legs. Okay. How do we prove the Pythagorean theorem? I use the geometry sketchpad to help us to easy to prove this theorem, because the geometry sketchpad has a lot of features that are very useful to prove this theorem. For example, the measure features. We can use this measure to measure the length of the side of this triangle or the area of this triangle. Now look at this triangle. C is the hypotenuse while A and B are legs. Now I will draw a square in each side of these triangles. This is the result. We have 3 squares. Based on the prerequisite material, we can determine the area of these squares. For example, square 1. It has a side length A. So the area of square 1 is equal A square. With the same way, the area of square 2 is equal B square, and the area of square square 3 is C square. Now I will measure the area of these squares. Use measure feature, and this is the result. The area of square 1 is equal 9.12 centimeters square. The area of square 2 is equal 24.72 centimeters squares, and the area of square 3 is equal 33.83 centimeters squares. And then I will add the area of square 1 and square 2. So this is the result. Now compare this result. You can see both of the results are equal. Okay, I will change the measure by drag this point. Now you can see the size of the triangle of this triangle is changing. What about this relationship? Yes, the result is still same. Okay, I will drag again to become smaller and observe the result. Yes, the area of square 3 is equal the sum area of square 1 plus square 1 and square 2. Still same. So from this finding, we can make the formula of this relationship, that the area of square on the hypotenuse is equal the sum of the area of square on legs. Or we can write down here that c squares is equal a square plus b squares. C squares is the area of square on the hypotenuse, while a square and b square is the area of square on the legs. Okay, with other words, we can state that in a right triangle, the square area on the hypotenuse is equal the sum square areas on the legs. This is the Pythagorean theorem. Okay, to deepen your understanding, I want to repeat again. Look at this triangle. It is ABC triangle, and I give the name. In front of angle C is side C, in front of angle B is side B, and in front of angle A is side A, with C is the right angle. From this triangle, we can make the Pythagorean theorem that if triangle ABC is right triangle with angle C is the right angle, then C square is equal A square plus B square. From this statement, we can make the converse or the converse of the Pythagorean theorem. This is the converse. In triangle ABC, if C square is equal A square plus B square, then this triangle is right triangle with angle C is the right angle. This is the Pythagorean theorem, and this is its converse. Next, look at another triangle. The name is still same, triangle ABC. And in front of angle B is side B, in front of angle C is side C, and in front of side angle A is side A. I will measure the length of these sides. This is the result. Side C is the longest side because the length of side C is equal 6.24 centimeter, which is the longest compared to other sides. And then I want also measure the angles. So this is the result. Angle A is 36.21 degrees. Angle B 66.10 degrees. And angle C 77.69 degrees. All these angles are acute angle. So based on this angle, what is the type of this triangle? Yes, because all of the angles are acute angles, so this triangle is acute triangle. Now I will draw a square on each side of the triangles like the previous one. And then I will also measure these areas. Look at this. The square one is the biggest. the area of square 1 is equal 38.90 centimeter squares. Now I will add the area of square 2 and 3. This is the result. Now compare the result. Yeah, from the result we know that the area of square 1 is smaller or less than the sum of the area of squares 2 and square 3. Now what happens if I drag this point becomes smaller maybe? Okay, look at this relationship. The triangle is still acute triangle, and what is the relationship? Is the relationship changing? No, the relationship is still equal, that the area of square 1 is less than the sum of the area of square 2 and 3. From this finding, we can write down the formula that if the area of square on the longest side is less than the sum of the area of square on the other side, then the triangle is acute triangle. Okay, next I have the other triangle. The name is still same, ABC, and also the name of its side. In front of angle C is side C, in front of angle B is side B, and in front of angle A is side A. I will measure the length of these sides. This is the result. C is the longest side because the length of C is equal 9.35 centimeter, which is the longest compared to the others. And then I will measure the angles. This is the result. Angle C is equal 148.14 degrees. Angle B is equal 16.75 degrees, and angle A is equal 14.84 degrees. One of these angles is obtuse angle, while the other angles are acute angles. So based on this angle, what is the type of this triangle? Yes, you are right. The type of this triangle is obtuse triangle. Now I will do the same thing. Draw a square in each side of this triangle, like this. And also I want measure the area of this square. This is the result. So the area of square 1 is the biggest square, is 87.34 centimeter squares. And now I will add the area of square 2 and 3. So this is the result. Now you can compare the result. So we can state that the area of square 1 is greater than the sum area of the square 2 and square 3. If I change the size by drag this point, the triangle is still obtuse triangle. And what about the relationship? Is the relationship changing? No, the area of square 1 still greater than the sum of the area of square 2 and 3. So from this finding, we can make formula that the area of square on the longest side is greater than the sum of the square area on the other sides. Then this triangle is obtuse triangle. Okay, we can make a summary from this video. In triangle ABC, with C is the longest side. C is the longest side. 1. If C square is equal A square plus B square, then this triangle is right triangle. But if C square less than A square plus B square, then this triangle is acute triangle. Or if C square greater than A square plus B square, then this triangle is obtuse triangle. I hope you really understand with the Pythagorean theorem. If you still have difficulties, please rewind again this video and take some important notes. Tomorrow we will discuss this theorem. Okay, that's all and goodbye.